Hello and welcome to Hydromantis webinar. Today we are going to show you some of the new features in CapdetWorks version 3. So my name is Rajiv Goyal and I'll be showing you some of the new features in upcoming CapdetWorks. And I have my colleague Spencer Sloaney here who will be talking about some of the new things going on at Hydromantis at the end of the webinar. And then we will take some questions from you and take some time to answer those questions. So first of all, giving you a little bit of a background about CapdetWorks. CapdetWorks is a tool which can be used for designing and costing wastewater treatment plants. It's an acronym coming from the Computer-Assisted Procedures for Design and Evaluation of Treatment Systems. And this is a program which has been developed by Army Corps of Engineers. And later on, with a contract from US EPA, it was released in 1982. The main purpose is to design wastewater treatment plant and kind of make some costing estimates for different wastewater treatment plant alternatives. So Hydromantis ported CapdetWorks in 1985 to a PC environment so that it can be distributed to a wider range of people or the users. So the main function, as I said, for CapdetWorks is it can be used for designing individual unit processes based on a user-specified treatment plant layout. So CapdetWorks contains a large number of unit processes which can be used to build various process layouts, and depending on the criteria which are the design criteria which are built into CapdetWorks software, the software makes the design for individual unit processes. After the design is done, the costing of each unit process is carried out based on different methodologies which are built into CapdetWorks. CapdetWorks also provides you with a design override capability. So in some particular cases, the designs which are produced by CapdetWorks are not the designs. Maybe you want to make a certain change in the designs. So it allows you to actually override the designs which are provided by CapdetWorks and then allow you to cost the modified designs. If we look at the workflow for the CapdetWorks, there are primarily three steps. The first step is layout specification for a treatment objective. So once you have your treatment objectives, for that particular objective, you are going to build a layout in CapdetWorks and specify some of the design conditions which you would like to have. Also make adjustments to some of the parameters that are required for costing the layout. Once you have done that, the second step is the process design calculations, which are automatically done by CapdetWorks. During this step, we are estimating, for example, what are the volumes required, what are the airflow requirements for that particular unit process, and based on those estimates, estimates are then fed to the costing module where different cost calculations are done. So if we look into the cost calculations for individual unit processes and see them in a little bit more details, we can see that CapdetWorks actually does the construction cost estimates for you for each unit process, and it also takes into account some of the other costs like the cost of the site preparation, piping, mobilization, and also takes into account some of the other administrative costs which could be there. For example, the profits, engineering costs, and all those costs are accounted into the construction cost. All of these costs from the unit process cost and the other costs, which are the capital costs, are then kind of amortized and added to the annual operation and maintenance costs, which are also estimated by CapdetWorks to find the net present worth of the project. If we look a little bit more closely on the unit process cost, how these costs are estimated, then these costs actually include two components. One is the structural aspect, another one is the equipment aspect. So for the structure, we estimate the concrete amounts, earthwork required, piping required, and some of the other components for that particular unit process. And after estimating different component of the cost, these costs are then multiplied with the unit costs which are specified by the user, and the cost of the tank or the structures are estimated. Built into the process is the estimation of equipment. For example, if we're talking about activated sludge tanks, then we know that there are blower requirements. If we're talking about clarifiers, then there are pumping requirements. So all those equipments are automatically estimated by CapdetWorks, and using equipment cost database, which we are going to talk about a little bit later, we estimate equipment cost and the cost of installation to find out the installed equipment cost for a given unit process. In the other cost, other construction cost, we have two different types of costs. One is the direct construction cost and indirect construction cost. In the direct construction cost, we are taking into account mobilization, site preparation, yard piping, site electricals, instrumentation and control, lab and admin building. All of these costs are estimated based on some of the parametric equations which have been developed based on a large amount of data, statistical data that has been collected during the development of CapdetWorks. In the indirect cost, we have land cost, legal cost, engineering design fee, inspection cost, technical cost, profits, interest during construction, contingencies, and miscellaneous cost. So all of these are calculated as a percentage of the cost of the project, and user has kind of a good handle on what they want to specify these costs to be. The next part of the cost calculation is operation and maintenance cost. In the operation and maintenance cost, we are estimating operational man hours, maintenance man hours, power requirements, and chemical requirements. All of these estimated quantities are then multiplied with unit labor cost, electricity cost, and chemical cost to find out individual labor cost, power cost, and chemical cost for the whole layout. The typical uses for CapdetWorks are CapdetWorks is quite extensively used for planning level design. For example, if you have a kind of a project in which you just want to quickly find out what could be the best configuration for given treatment criteria, then you can use CapdetWorks to do a quick design for you. It also gives you the capital cost, and based on a large number of studies, it appears that the cost, calculated cost coming out from CapdetWorks are within plus minus 15% of the actual cost. Also, with respect to operation and maintenance cost, it is suggested that the costs are plus minus 20%, which are calculated from CapdetWorks. Also, the second use, which typically CapdetWorks is used for, is screening of various process alternatives. For example, for both new facilities and if you are doing some kind of upgrade and retrofit options. In that particular case, if you are evaluating, for example, the use of different technologies, then in that particular case you can construct many different layouts and try to do a comparative analysis on the different alternatives and evaluate them from the cost perspective. Also, sometimes when you are trying to meet new regulatory criteria and you are trying to phase out your plans for improvements, in that particular case, CapdetWorks can also provide you estimates that you might be needing as you go forward in implementing those changes. CapdetWorks can be used for bid evaluation, and some of the latest use we have seen is in the insurance industry. So some of the insurance companies kind of trying to use CapdetWorks to get an idea about what could be the present worth value of these treatment plants for insurance purpose. Until now, our latest version was 2.5, and we have done quite a lot of development, and we are happy to announce that we'll be releasing our new version, version 3, on 1st of December 2014. So now coming to the main topic about what is new about in version 3, I would like to just show you some of the new features which you would be seeing in CapdetWorks version 3. So first of all, we have done quite a lot of work in updating our graphical user interface. So we have tried to make it look like our other products like GPSX and ToxChem, so it has a very similar look and feel to our other products, and makes it easier for a user who is using multiple products to use products without much differences. So it has a little bit of a new look and feel. Also, we have a larger drawing board. In our earlier product, we had only 40 unit processes that you can use or put on the drawing board in a layout. So now we have expanded that capability to include more than 600 unit processes you can put on the drawing board if you want to. Also, we have quick output panels on the main drawing board. Along with the main drawing board, we have quick output panels which can be used to quickly see the cost summary of the layout, and also see some of the quality indicators to see how each unit process is performing with respect to water quality. Also, we have done some reorganization of our cost reports to make them more understandable, easy to understand. So that is a change which we have made. In addition to that, we have added a number of unit processes in new CapdetWorks. So one of the biggest requests I think we had in previous years is the inclusion of moving bed biofilm reactor, IFAS reactor, membrane bioreactor. So we have included all of these 3 reactors or 3 new processes in the new version of CapdetWorks. Also, we have made some small modifications into our secondary clarifier model, in which we have included another criteria of solid loading criteria. Earlier, it was just based on overflow rate criteria. The design criteria was overflow rate, but we also included the solid load criteria in the new in the revised version of secondary clarifier model. We have done some changes to our cost database. So the first change is we have updated the equipment cost database. So earlier cost database was indicative of the year 2007, but the new version, new database is updated to reflect the current year 2014. Also, we have updated the unit cost database that is built into CapdetWorks. One of the most significant feature is we are introducing Hydromantis cost indices now built into the cost databases. So there is an additional database which actually is based on the Hydromantis cost indices rather than the standard cost indices that we have been using until now. So user has the flexibility to either use the standard database, which is based on Marshall and Swift, ENR, and chemical engineering cost indices, or they have the choice to choose Hydromantis cost indices. The benefit of using Hydromantis cost indices will be that the user can update these indices through our website by connecting to our website. In addition to that, we have fixed many bugs which have come to our notice over a period of time. With that, I would like to give you a demonstration of the new version. So the new version, the drawing board or the first screen when you open CapdetWorks is going to look like this. On the left-hand side, you will see that we have a kind of grouping of the objects. And we have made some changes to the grouping of the objects just to make it more systematic to the workflow or how the treatment plant layout is constructed. So you will see some changes there, but all the unit processes which were there in 2.5 are still available in 3, although their location might have changed a little bit. Also on the bottom side, you will see at the bottom you will see a new panel, and this panel is the quick panel that provides the summary of the cost summary for the layout. Also you can change it to water quality by process, or you can change it to water quality by state. So it is a kind of a much nicer way to visualize the information quickly for each layout. Also, as I said, we have a larger drawing board here, so there are, you can see that number of trace points there is quite extensive. You may not use all of them, but in case you need to use or build a larger layout, you can use the larger drawing board. Another thing I talked about is the equipment database. So if we go to the cost database here, we can see that we have equipment cost database. And like I said, we have now a new database which we're calling Hydromantis 2014 USA average. And as you would notice that the index value for three of the new indices which we are introducing, construction cost index, equipment cost index, and the piping cost index. So there are 3 indexes which we are introducing here. And value for the year 2014, we are starting with a value of 100 there. In case you feel comfortable using Marshall and Swift, then the standard database, we do have that standard database feature as well, and you can have the values of ENR, Marshall and Swift, and the pipe cost indices there. So in case you want to use this database, then in that case you need to know the current values of ENR and Marshall and Swift from their databases. So so you have the choice here, and the way it works basically is that when you're going to the cost indexes, for example, if you're using the Hydromantis database, then in that particular case, your year 2014, the index value is 100 for all the 3 indices. So when you want to bring the current values here, you can just press update, and it will update the values from our website. So in that way, it makes your work a little bit easier, that you don't really have to go and search the values from those standard databases. So now I would like to highlight the new processes that we have introduced. So if you go to the suspended growth carbon and nitrogen removal category, you will see that we have a process which is a plug flow activated sludge with MBR. So this is a process at the end of this plug flow tank, you have a MBR unit process. For the IFAS, if you go to the attached growth, then you have the option of MBBR and IFAS unit processes, which can be used. So IFAS unit process automatically connects the clarifier and brings the sludge back to to the activated sludge tank. For MBBR, you have the choice to put the reactor and use either any of the solid liquid separator which you can connect at the effluent of this MBBR here. So also we have MBR reactors for carbon nitrogen denitrification and phosphorus removal. So you will see there are several reactor configurations which we have in all the new unit processes, including MBR for pre-denitrification, MBR for post-denitrification, DNR with MBR, and DNR 2-stage with MBR, and DNR 3-stage with MBR. So you have a choice of reactors which you can use with MBR configuration there. Now I would like to show you the use of this unit process through layout comparison. So I have prepared a layout here in which we are trying to compare activated sludge process with MBBR, IFAS, and MBR unit processes. So in this particular layout, We have an influent, a grid chamber, primary clarifier, activated sludge tank, secondary clarifier, chlorination unit, and the sludge from primary clarifier and the secondary clarifier are fed to digester. The digested sludge is taken and disposed of. So that is the kind of layout we are trying to evaluate here. And the difference between MBBR and this layout is we have replaced the activated sludge reactor with the MBBR reactor here. And for the IFAS, now you can see this recycle line coming back to the MBBR reactor there. For our MBR reactor, we have the plug flow tank and a membrane separator. So these 4 layouts are different how the biological, they are different with respect to the biological stages. And if we try to run this layout, for example, going to model, and we cost these layouts and run all of these layouts, we can see and compare the present work of each of these layouts. So for activated sludge, MBBR, IFAS, and MBR layouts, we can see how is the cost difference between the 3 layouts for the conditions which we have set in the layout. So from this analysis, it appears that activated sludge is the cheapest option. MBBR and IFAS are pretty much, they are higher than our activated sludge process, but they are pretty comparable. MBR reactor seems to be the highest price there. And then we can go further and try to see where this difference is coming for different alternatives. We can see that some part is coming from the capital cost itself, and some part may be arising due to the operation and maintenance cost that we need to do, that is required for handling these 3 for all these different layouts. So one major component you will see is that the difference in the energy requirements. So and this energy difference is directly the reflection of how the aeration differences in the 3 biological reactors. There are differences in the aeration strategies and the oxygen transfer efficiencies that happens in the 4 unit processes there. Now, once we have done the costing, also it gives you the details of the design here. So, for example, if we want to look at the design information, it gives us, for example, for the activated sludge, if we want to look at the plug flow activated sludge design information, we can look at all the volumes of the reactors, what is the length of the train, width of the train, all the side water depth, and all that information is available to the user. Also, in the costing tables, one of the change we have made in the new version is that instead of just reporting a construction and equipment cost, which was a lumped cost in the previous version, we have tried to segregate the individual items that are estimated for each unit process. So this way, it gives the user kind of more information, and they can judge from based on the produced information whether the information is in the right range, and if necessary, they can make changes to those information. One of the things which I would like to highlight also is the design criteria that have been used for MBBR. So in this particular case, if I show you some of the input parameters that are required for modeling MBBR reactor, is the type of media that you're using. So we have set different type of medias which are different from the specific surface area that is being used. So you can use one of the media which is specified here, or you can specify your own user surface area by selecting specify surface area in this drop-down menu. Why we need this kind of information is because based on our analysis of the cost for different media, we found that the cost per meter cube of the media is a direct function of what is the specific surface area of the media itself. So that's why we have developed a cost function which directly takes into account the specific surface area of the media in costing it basically. So if you're using a media which has a higher specific surface area, then the per cubic meter cube cost of that media will be higher than media which is actually lower in specific surface area. Another thing which we need to specify is the use of biofilm thickness, or you can specify directly what is the maximum biomass density in this particular design setup. Also, we are asking you to specify the maximum BOD surface area loading rate and ammonia nitrogen surface area loading rate. Two other parameters that are required are media fill fraction and water displaced by the media. So after we have set up all this information is used for designing the reactor. Also, with respect to diffuse aeration, the standard oxygen transfer efficiency, because most of the aeration types that are used for MBBR reactors are kind of coast bubble aerations. So we have used a lower standard oxygen transfer efficiency for this particular case. You can, if you have evidence that it is a higher efficiency, you can make changes to this particular parameter here. Also, there is a replacement cost that affects the costing. So for the media, we have taken 10 years as a replacement cost for the media. You can make the changes here if you want to make, if you have more information from the manufacturer. Also for MBBR reactor, we have number of input parameters that are required. The most important one being the average net flux and the peak net flux that is provided by the user here. So we have set up some default values based on which we are estimating the amount of membranes that are required, and also a packing density for the membrane that is used to estimate the area and the membrane surface area that is required. We are also estimating how much air will be required, the scouring air demand that is inputted by the user into the menus, and based on the cycle time, we are estimating how much energy will be consumed for the scouring. Also, there are some other parameters with respect to physical and chemical cleaning, which needs to be provided by the user. Here, again, we have the membrane replacement cost, replacement for 10 years, and the user can change this particular values if they have more information. So with that, basically, I think I have explained all the new features in upcoming CapdetWorks there, and so it retains all the features which it had in 2.5, but it provides you with a little bit with an updated interface and some of the newer process icons that are kind of have been requested over a period of time from us. So just before finishing up, I would like to show you the use of this this panel here at the bottom. So like I said, it can be used for cost summary here. So if you click on any particular unit process here, the bar automatically takes you to that particular unit process, and you can analyze the cost of that particular unit process. Also, there is water quality by process. So in this particular case, if you are interested in looking at what are the water qualities, you can click on the objects, automatically changes the unit, selects the unit process here and shows you what are the influent, affluent, and sludge characteristics from that particular unit. Also, they are also summarized by water quality by state. So if you are interested in looking at just the number for BOD all across the plant, you can just use water quality by states. So all of this information also can be copied to an Excel sheet through these icons provided here, and it provides you a kind of a quick way to extract information, only the information that you need, and put it in a report. So provides you kind of makes your workflow pretty efficient, and you can get your work done quickly. Now coming back to the PowerPoint there. So in summary, we have CapdetWorks, which will be released on 1st of December 2014. It has been quite an extensive development with respect to graphical user interface, course database, new indices with online updates, and new process models for MBBR, IFAS, and MBR. So the people who are with yearly subscription or who have a valid tech support license contract, they will automatically receive kind of a notification from us to get this update. The people who don't really know whether they are up to date or they automatically qualify for an upgrade can contact us at support@hydromantis.com and would be happy to assist you if you are interested in upgrading your license. So with this, I would hand it over to Spencer, who would inform you some of the new upcoming things at Hydromantis. Thank you very much.
Thank you, Rajiv. So I have very quickly a few slides here that indicate some upcoming things that we have going on at Hydromantis. For GPSX users, we are now offering an open online GPSX workshop. This is a shortened version of our training session, and we are going to be offering these on a regular basis over the coming year, and these will be carried out as a series of half-day courses. The very first one that we're offering here is an introduction to activated sludge modeling in GPSX, and that will be a hands-on course similar to the way that we offer these webinars, but it will be a 4-hour session, and that will be happening on December 4th, 2014, from 12 noon to 4 p.m. Eastern Standard Time. In these sessions, there will be a live interactive session with, I'll be running this first one myself, so there'll be somebody there who can do all the demonstrations live for you and answer questions as we go. We're going to be covering the very basics of modeling, how the activated sludge models work and what their equations are. Also talk about our clarifier models, and there'll be a few exercises that we are going to work our way through as well. And we're going to use the GoToMeeting, which is very similar to the service that we're using to bring you the webinar today. So the cost for this online GPSX workshop is $495. That's for a first registration, and $295 per additional person from your institution. And for that, you'll get access to the training session, the training materials. Training certificates will be issued at the end for those that have completed the course. And we do require that you have a GPSX license to be able to go through the exercises that we're going to provide to you. If you'd like further information, you can go to our website, or you can contact us by emailing us at training@hydromantis.com. If you are at our website and go into the resources section, there's a section there called training, and you can find there some more details about our upcoming sessions and also the registration form.